Okay, so first off, we're looking at rounding, and in your exam, they can ask you to round one of two ways. They can ask you to round either to a given number of decimal places or to a given number of significant figures. So what we're going to do is we're going to have a look at what both of those mean and look at a couple of examples that involve us rounding to each of them. So the first one that we've probably dealt with before are decimal places. We might not have seen significant figures before. So looking at decimal places then, what are decimal places? Well, when we round to a given number of decimal places, what we want to do is we want to keep some of the numbers after the decimal point and we want to ditch the rest of them. Okay, so we've got a really big decimal number. There's no need to include all of that detail. We'll get rid of some of them, but the question is going to tell us how much it wants us to keep. So what we need to be able to do is we need to be able to decide whether or not we're going to round it up or round it down. So, for example, if we look at 13.63278 and we want to round it to one decimal place, what we're saying there is we want to keep one number after the decimal point. So the first number after the decimal point is a 6. So what we want to be able to do is ditch the rest of that stuff that's there in red, that 3278. So what we're going to do is we're going to check if the digit after the 6, so in this case 3, is 5 or above. It's not 5 or above, so it gets to stay at 13.6. So my answer there to one decimal place is 13.6. If we want to round it to two decimal places, again, what we're saying is we want to keep two things after the decimal point. So here, we're going to keep it to be 13.63, and we're going to ditch the 278 at the end. So we're checking the digit after the 3, in this case it's at 2, and so again, it gets to stay at 13.63. Finally, looking at three decimal places, and theoretically we could go more than that. We don't tend to ask for any more decimal places than 3, but if we look at it here, we want to keep three things after the decimal point. So we've got 13.632, and we want to ditch that 7 and 8. So what we're doing now is we're looking at the digit after the 2, the 7, but in this time it is bigger than 5. Okay, and so in that case what happens is we round it up, and so it becomes 13.633. And remember, when we're doing this, it is just that final digit that we are adding 1 onto. Okay, we don't need to stick a 1 in anywhere else. It is just that final digit. The only exception is when that becomes a 9. We add on to that, but we'll look at an example for that later. So it's only the final digit that we are changing. So another example, we run around 18.799634. Well, the first thing we're looking at is one decimal place. And again, looking at that, there's a lot of detail given after that decimal point, and we just don't need it. Okay, so we're going to try and ditch some of it, make our answer look a little bit tidier. So we're going to keep it to be 18.7, and we want to ditch everything else after that. So we're going to check immediately after the 7, is it 5 or above? Yes, it is. And so we're going to round up, and so it becomes 18.8. We want to round it to two decimal places, it would be 18.79, and we're going to ditch the rest of it. So we're checking after that, is it 5 or above? Yes, it is. So we round up. But when we're adding the 1 onto 9 here, you add 1 onto 9, it gives you 10. Okay, and so in this instance, what it actually becomes is it's going to become 18.80. Okay, now the temptation here is to leave it as just 18.8, but it has asked for two decimal places, so we need to make sure that we keep the 0 on the end of it. So we need to leave it here as 18.80. Finally, we think about three decimal places. Same idea, we want to ditch that 634, but at the end we're checking after the final 9 what digit comes next. Is it 5 or above? Well, it is a 5 or above, it's a 6. So again, we need to round up. And we've got the same problem as we had before. When I add 1 onto my 9, it becomes 10. And then when I add that 1 onto the other 9, it becomes 10. And so I end up actually getting 18.800. Again, we need to make sure that we're adding the extra zeros on to keep this number right. Now, what we can do to sometimes try and help make this a little bit more sense is we're going to think about it where they lie on the number line. So thinking about the first one, when we did it to one decimal place, we had 18.799634. So what we want to know when dealing with one decimal place, is it closer to 18.7 or 18.8? And so I've got my number line, I've got my 18.7, and we're right, it's 18.70 to 18.80, just so that the the increments in between make a little bit of sense. So I'm thinking about my number. Where does my number come on the line? Is it closer to the left-hand side or the right-hand side? Well, if we place it on 18.799634, it comes all the way over at that side, and it pretty much comes on top of that 18.80. So even if we just think about where it comes in the number line, we can see that that number is much closer to 18.8 than it was to 18.7. Okay, there are the words on the screen. So we're going to do the same thing, but with 2 decimal places this time. So again, we want to see whether 18.799634 is closer to 18.79 or 18.80. So we are going to think about our number line, and again, I'm going to write it as 790 to 800, just so that we can try and make a bit of sense as to where our number's coming on this. But it's 18.799634, so again, it's coming pretty close up to that top end. And so again, we can see that it is much closer to the 18.80 than it is to 18.79. Okay, finally then, we're looking at 3 decimal places, so 18.799634, and I want to keep those 3 bits. So again, I'm looking to see, is it closer to 18.799 or is it closer to 18.800? Okay, so again, what we're thinking about, is it closer, when we're looking at the white number here, is it closer to the bit that we're at or the next one along? So 18.7990 all the way up to 18.8000, and I want to see where this number comes. Well, if we place it on our number line, it comes in there. And whilst that one is still a little bit closer to the middle than all the other ones have, it is still closer to 18.800 than it is to 18.799. Okay, so there's number line work just to help us. Next thing we need to look at are significant figures, and these are probably things that we've had a lot less experience with. So when we're looking at it, we need to try and remember what digits are significant. So when we're dealing with these, the digits 1 to 9, right, or 1, 2, 3, 4, 5, 6, 7, 8, 9, are always significant. And 0, as a rule, is not significant unless it either comes between 2 significant digits or it comes at the end of a decimal. So let's have a look at some examples. Right, so how many significant figures are in each of the numbers below? So looking at that one, first thing I'm doing is I'm looking for how many digits are there that fall in my 1 to 9 category. Well, there's just 7 there, so there's 1. And then I'm looking at my zeros, okay, because 0 is not significant unless it's either at the end of the decimal or between 2 significant figures, and neither of those zeros meet that standard. So there's only 1 significant figure in that number, because the zeros don't meet our criteria above. Looking at this next one then, 404. First thing I'm doing is I'm looking at my non-zero digits, so I've got 2 of them straight away, a 4 and a 4. And then I'm looking at my 0. Well, this time my 0 is sandwiched between 2 significant things, and so the 0 there is also significant. So in this case, all 3 of my digits are significant. So there are 3 significant figures here in this number. Next one, I've got 0.0025. Again, I'm putting on my non-zero digits first. There are 2 of them, the 2 and the 5. Next thing I'm looking for is how many of them come between 2 significant figures and how many of them come at the end of a decimal. Well, none of those zeros meet that criteria. There's one at the start of the decimal, but there's not one at the very end of that number. So here, it's just our 2 digits at the end of the number. Looking at this one, we've got 1.00040. So again, first thing I'm doing, I know that my 1 and my 4 are significant. They're always significant. Next thing I'm doing is I'm thinking about where my zeros are. So here, I've got 3 zeros sandwiched in between 2 significant digits. And so in this case, those 3 zeros become significant also. Finally, there's 1 0 stuck on at the end of the decimal, and so it becomes significant as well. And so we find here, all 6 digits in that number are significant. So when we want to round with significant figures, we tend to use rounding to significant figures when we're looking at much larger numbers. Okay, so if we take, for example, the number there, 3,245,691, a lot of detail in there. Okay, but our most significant digit is the 3, because it doesn't count for just 3, it actually counts for 3 million. Okay, and our least significant digit is the 1 at the end, because it still just counts for 1 unit. Okay, that was the amount of money you were to have, and you changed the number in the millions column. You would probably notice that a lot more than if you changed the number in the units column here. Right? So if you went up to 4,245,691, you might notice that. But if you went up to 3,245,692, you would notice that a lot less. Okay, and that's what we're trying to think about here, is how much our numbers are actually worth. So our 3 is much more significant than the 1 at the end. Okay, when we're dealing with these, our most significant digit is the number furthest to the left. Okay, when we want to round to significant figures, it follows the same principle as before. We're just looking in a different place for it. So if we want to round this number here, so we've got 4,378,926 to one significant figure. We want to keep the most significant digit, the one furthest to the left, and we want to ditch everything else. So I'm looking at my 4, I'm checking the number immediately after it. Is it 5 or above? Nope, it's a 3, and so the rest of them then just become zeros. And all those zeros are doing is they're keeping that 4 out in the millions column. Right? If I didn't write those zeros there, I would just have 4, and that's not worth the same. If we want to look at 2 significant figures, then we're going to keep the first 2 digits, and we're going to ditch the rest. And so I've got my 4, and I've got my 3. So I'm looking at the number immediately to the right of that, and I want to see what happens. So it's a 7, which is 5 or above, and so it rounds up. And so I end up getting 4, 4. And then every digit that's there in red just gets replaced with a 0. And finally, if we want to look at 3 significant figures, we've got 4, 3, 7, and then we've got my 8, 9, 2, 6 are in red. So is my 7 going to stay as a 7, or is it going to round up? So again, we're checking the number to the right. Is it 5 or above? Yes, it is. It's an 8. And so we can round the 7 up 1. And so it becomes 4, 3, 8. And all those digits that are in red just get replaced as zeros. Okay, when we're doing these, we're always leaving the most significant digits, and the rest of them just get turned into what we call zero placeholders. So it just keeps those numbers out in the right column. And that